In this next section, we're going to look at how to find probabilities when we have a normal distribution that is not the standard normal distribution. That means the mean is not 0 and the standard deviation is not 1. So to start, let's review the idea of finding probabilities with a standard normal curve. All right, so try this problem on your own and then check your answers. Alright, since we are looking at the z-score between negative 1.53 and 0.83, I'm going to start by drawing my normal curve. Right here, we'll have the mean of 0. We have a z-score of negative 1.53 around here, and a z-score of 0.83 about here, and we're looking at this area in between. So, if I go to the calculator and I type in normal CDF negative 1.53 comma 0.83, this gives me the probability of 0.7337, right? Or the area between these two z-scores is 0.7337. Right? So as we start to think about any normal distribution, not just the standard normal distribution, we need to remember our z-score formula. Right? So if a random variable x is normally distributed, you can find the probability that x will fall in a given interval by calculating the area under the normal curve for the given interval. Right? This is exactly the same thing we did with the standard normal curve. So to find the area under the curve, you can first convert the upper and lower bounds of the interval to z-scores. Right? And remember, we use the standard normal distribution to find these areas. So we're basically taking any normal distribution, and by finding the z-scores, sometimes the z-scores are referred to as standard scores, we're standardizing these other distributions. We're making their mean equal to 0 and their standard deviation equal to 1. That way we can use the standard normal distribution to find the probabilities. All right, going on to the next slide then. All right, let's start to see how this works. So here in the first 4 examples, the mean is 212. So our mean is 212, and the standard deviation is 35. So, going to find the probability that x is less than 230, this time when I sketch my normal distribution, my mean is not 0 right now. My mean is 212, as given to us in the problem. Now our standard deviation is 35, so 230 is going to be within one standard deviation. I'm going to estimate that it's about here. We want the probability that x is less than 230, so we're looking at the area to the left. So right away from my sketch, this is going to be more than half, so I can expect my answer to be more than 0.5, and if it's not, I should double check my work. Now, next, we go back to using our probability notation that we used in the previous units, right? And as we use that probability notation, we're going to change the values. We're going to standardize them. So in my next step, I'm going to convert 230 to a z-score for this distribution. So since I'm converting it from a data value, we use x to represent a data value, I'm now going to use z because it's going to be a z-score. And I just use my z-score right here within the probability problem. So I do my data value, x, minus the mean, 212, all divided by the standard deviation, 35. So if you're using a calculator on this, just remember, if you're typing this all in at once, use parentheses around the numerator. And this comes out to a z-score of 0.51. So I rewrite my probability statement with the z-score of 0.51. Now we have a z-score, so we use the standard normal distribution. We can just do this with the table or with the calculator. So if I use the calculator, I would type in normal CDF we're less than, so we want negative 10,000, comma 0.51. And this ends up giving us 0.6950 when we round to 4 decimal places. Right? And as expected, this is greater than 1/2. Alright, in our next example, we're looking at x being greater than 242. So if I sketch my normal curve, right, our mean is again 212, just like the last problem. And we'll say 242 is about here. And we want greater than, so we want this area to the right this time. So I will standardize my data value, so I use z instead of x now, and I use my z-score formula where I take my data value, 242, minus the mean, divided by the standard deviation, and this gives us a z-score of 0.86. So again, either using the table, if we use the table this time we would have to subtract from 1 because we have a greater than probability, or if we use the calculator we would just use normal CDF 0.86 comma 10,000, and this comes out to what does this come out to? I believe this comes out to 0.1049. Sorry, 0.1949. On the next example, we're looking between two values. So our mean is still 212. Now we're going from 189 up to 225. So we're looking at this area in between two data values. So now I have to do two z-score calculations within this this notation. So I have the probability convert the first data value using my z-score, data value minus the mean divided by the standard deviation. I use z instead of x, and then my second data value, 225 minus 212 divided by 35. And doing the calculations for both of those, we are now looking between negative 0.66 and 0.37. So those are our z-scores. And using the calculator, we would want normal CDF negative 0.66 comma 0.37. Right? If we're using the table, we would look up 0.37 and we would look up negative 0.66, and then we would subtract those two values. Either way, this should come to 0.3877. And then the last example, we're looking at the probability that x is greater than 10. So on our normal curve for this distribution, right, our mean is still 212. And with a standard deviation of only 35, the data value 10 is way over to the left, really far to the left. We want the probability that x is greater than 10, so it's this whole area over here. Right, now if I go to standardize this, it'll be z is greater than taking 10 minus 212 divided by 35. This will give us a z-score of negative 5.77. So this is almost 6 standard deviations below the mean. Right? It's 5.77 standard deviations below the mean. And we're looking greater than that, so we're looking at the majority of the area here. Right? Whenever we enter this into the calculator, if we use the normal CDF negative 5.77 comma 10,000, the calculator gives us a lot of decimal places, and a lot of those decimal places are 0.9. So 9999, and then it keeps going until we finally get to our first decimal place that is not a 9. All right, so when we answer this, we don't want to round it all the way up to 1 because we don't have an area of 1, right? Because the normal curve keeps going on forever and ever in both directions, right? So we want to just leave this 0.9999. Right, so now try the next 3 problems and then check your answers on the next video.